Okay, cats and kittens, this is lesson 8 on circles. And following along with our theme of circles here, we're getting into the sector areas. That means that piece of the pie right there in blue. So what we're going to be doing over here is taking this whole area of a circle and taking a fraction of it. But first, the whole area of a circle is pi r squared. You got to know that. So a little previous knowledge. And then we're going around the outside. We're taking the circumference and we're going all the way around, but we're not going all the way around. We're just going for that sector. That is what we call arc length. So we turn arcs before, we were talking about the arc and the central angle. Now we're actually talking about the distance around the circle, which is the circumference. And if you're like me, I really like this formula right here, pi times the diameter. You can use 2 pi r, but twice the radius is the diameter. Pi times the diameter is the circumference, and that's just the easiest formula. So let's dive right in. To find the area of a circle, it's all about the fractions. So you're really just finding the area of a circle and the fraction. And if you're doing arc length, you're doing the circumference of a circle times a fraction. That's really what it is. And sometimes you can cut corners on this, and other times you need to be a little more specific. So let's just look at this one right here. The area of this shaded section right here, there's the radius, got that. And that means that the diameter is going to be 16. Okay, so the area, pi r squared. That's 8 squared times pi. And that's going to be 64 pi, but I'm not taking the whole thing. I got a central angle here of 180 degrees, so I'm taking 1/2 of that. So that would be 32 pi. And you can leave your answers in terms of pi here, for the most part. The only time you're going to get a real, go all the way, get rid of pi is if it's a real life problem. Then you can multiply it out. But for now, you don't need a calculator necessarily because we're working with pi a lot. Okay, let's go on over to the arc length with the 180 degree. There's the 180 degree central angle. There's the radius again. That means the diameter is still 16. So now we're talking about pi times the diameter. That's 16 pi. And we're talking about a fraction of it. It's going to be 1/2 of it because you can write it 180 over 360, but it's really not necessary. Shortcut a little bit here. Use your common sense here. Number sense. So 16 divided by half, that's going to be 8 pi. So we can see kind of the difference in the area of that circle, half of that, and the circumference, 16 pi, half of that. And we'll come on down, we'll take a look at one more here. This one's 6, we want the area. So we're going 36 pi. And it's 1/4 now. So we're just doing 1/4 of that. 36 divided by 4 is 9. And we just keep the pi where it's at. And then for the arc length, that's going to be diameter times pi. So that's going to be 6 times 6 plus 6. So that's going to be 12 pi. And it's still going to be 1/4 of that. So 12 divided by 4 is 3. All right. These don't change much. Just the numbers change a little bit along the way here. We do get some problem solving in lesson 9, but this right now we're really just doing the calculations. This is more the nuts and bolts. So let's come on over here to this. I got to figure out what I'm doing here. I've got a sector there, and I want the area and the arc length. So I've got to do both here. So let's do the area on top, the arc length on the bottom. So on top we got 10. That's going to be 100 pi for the whole area. And then it's 270, so it's going to be, that's 3/4 of 360. So 100 times 3/4, that's, think quarters here, 25, 50, 75. That's a 75 pi for the area. And I go down both the arc length. I'm using the diameter. So 10, 20 is 20 pi is the diameter times the circumference, and that's still 3/4. So that's 3/4 of 20 is going to be 15 pi. All right, number 2 here. Let's take a look at number 2. Same calculation, just different numbers. So 12, that means the 144 pi is the area. Radius squared times pi. And 60 over 360, you might know that. If you want to use a calculator, you can, but it's actually 1/6. So you might have to go, so you could do 144 times times 60 divided by 360. Or you can do 144 divided by 6. Same number, 24. So you're getting 24 pi as the area of that sector. In other words, the whole thing's 144 pi, you want 1/6 of it. And then you come on down to the arc length. You want the diameter here, so 12 plus 12, not 12 times 12, pi times the diameter, so 24 pi. And let's shortcut this. It's 1/6, so I'm just going to divide that by 6. 24 divided by 6 is 4. So I'm taking a few shortcuts here and there. That's okay, as long as you understand what you're doing with the numbers. Now this one with 135 is kind of weird. You got 16 squared times pi, and you got 135 over 360. So now there's no shortcut to this. I've got to actually do it all out. I'm going to leave the pi in my answer, and I'm actually going to go 16 squared times 135 divided by 360. And I'm getting 96 pi. So let's check that. Area of that sector. The whole circle's got an area of 16 squared pi, which is 256 pi. And we don't want all of it. We want 135 degrees out of the 360, so times 135 divided by 360, 96. All right, so you can kind of see how that's working. You come down to the bottom, you got 16 times 2 is 32. That's my diameter, times pi. And once again, I'm going to go with 135 over 360. You could reduce that fraction, I'm sure, but I'm not going to bother. I have a calculator. I'm not afraid to use it. 32 times 135 divided by 360. Oops, what did I do? Error on my calculator. Oops, too many multiplication signs. 32 times 135 divided by 360, and that's 12 pi. Unless I made a calculator error, which is entirely possible. So that's the idea, just making that same calculation, but here's what we're really doing again and again and again and again and again. We're really taking, for the area, we're taking r squared times pi r squared, that's the area, and we're multiplying by some central angle over 360. And for the sector length, that's really for your area of the sector, and for the arc length, you're really doing pi times the diameter, and then that fraction. It's always the angle, the central angle over 360. And that's again and again and again, that's the general formula, that's the method. So they'll repeat it right there. You can read the summary, pause the action. It's in your book as well. There's your notes on what a sector is. And bottom line, find the area of a circle, or find the circumference if you want the arc length. Take a fraction of it. That's what you get. Take a moment, lunchtime at the lab, pause it, check it out. And then since Forbes is not around, we miss him accordingly, but I cannot be him. So, see you, CDM.